do the area between the curves.
Hey, I'm probably going to be in my room.
Okay, so we're going to do more.
Somebody's leaving from Mexico tomorrow, so I need to gather up all this.
So, we did again volume. So, I'm going to go back and do volumes again, just if you're still missing something. Look at the videos, or think about your ebook, for example. Or just go to YouTube and you'll get some other things that maybe will help. There's so many things there to check. So the next thing what we're going to do, let's just go and just work with integrals. So we're going to have definite, indefinite, and we'll do a couple of them. Not like everything that's possible, just to refresh the ideas and methods. So this will be 4. Okay. So number 4. So for example, we have integral e to x over 1 plus e to x dx. So we have indefinite integral, so as the answer we're not going to have any numbers. Will be the function, don't forget to put plus c. So the main thing what we have to decide, like, do we need the substitution, or we can just maybe modify, change, whatever we can do here to solve the problem. And if I would take this as a function, and I think about table, right, of empty derivatives, there's nothing like this. And then if I think, okay, if I go to substitution, what would I use? So we may have, what will be the substitution? What is your guess here? 1 plus, right, e to x. Now, we may say, well, can we just use e to x? And the answer is not really. And you see, I didn't say no. I said not really. Why? Because if you use substitution just like u equals e to x, then you have to use the second substitution. So there will be 2 substitutions. So we include this 1. So the next thing, we'll take the derivative. So this will be just e to the x. And then dx will be du over e to x. So that's what we have. For the preparation, then we substitute. So e to x will be over u. That's our substitution. Then we'll have du over e to x. And the good news that these 2 will be canceled. And now we have integral 1 over u du. Well, and from here, what do we know? What's the antiderivative of 1 over u? Natural log. Right, don't forget to say absolute value. Okay, that's important. So it's natural log of absolute value of u and plus c. Now again, you must put absolute value. Then, going back to substitution, so we have natural log, absolute value of 1 plus e to x plus c. Now here, at this moment, you can actually drop the absolute value. Why? Because 1 plus e to x is always positive. So it's up to you. Okay, I'm going to say or, but if you keep absolute value, it's still right. Okay, but if you must have absolute value and you do not put absolute value, then it's really kind of wrong, so I'll take points off. So you have to be careful. But here we can drop the absolute value and put parentheses, because 1 plus e to x will be always positive. So this one will work fine, or this one. So we have to use substitution, okay? So let's go to the next one. Let's say 5. And this will be a little bit different. Let's say we have from 0 to 4. And we have absolute value. And we have square root of x minus 1 dx. Now, we have to solve this problem. And if you remember, if we have absolute value, we cannot just drop it, right? And with the absolute value, we must be careful. And our goal is actually to get rid of it. And in order to get rid of absolute value, you have to look at the picture. I'm not saying I'm using picture to solve. I just want to see how my graph will look like. And when I put my function, I don't put absolute value, okay? I'm putting just the function. So I have square root of x minus 1, no absolute value this time, and I will graph this. So I'll zoom in. So I don't see 4 here, so I'm going to go and change the window. So let's change this one to 5. So this is the picture. Now, why do I need this picture? Because I have to split, right, this integral into 2 integrals. Because that little piece that sits on the bottom right here, now don't forget this is still what? Area under the curve, right? So this little piece over here must go up. So in order for you to bring it up, you have to change the sign, right? So right now you have negative values, but if you move it up, you have what? Positive. So with absolute value, again, you cannot just draw up and think as absolute value instead of parentheses. No. So I have integral from 0 to 1. The intersection is 1, right? So we have integral from 0 to 1. And here now I have to put negative sign. So it's square root of x minus 1 dx. Again, remember, the whole goal is to make this area on the bottom, which is negative what? Positive, okay? And then the second piece goes from 1 to 4, and that's the piece that I have on the top, so I don't change anything. So this is the little piece over here. So I don't have to change anything on that one. So we have square root of x minus 1 dx. So no matter what function I have inside of the absolute value, graph it without absolute value, check for the piece on the right interval, of course, that you have that sits on the bottom, and separate into 2 integrals, and then just put negative sign. So when we go right here, what I'm going to do, I'm just going to distribute this negative sign. Okay, so I will have integral from 0 to 1, and I have 1 minus square root of x dx. Just, I don't want to keep the negative sign. Well, and the rest one I'm just going to copy because there's nothing else I can do with it. So it's from 1 to 4, sorry I was putting 0. From 1 to 4, and square root of x minus 1 dx. So that's the thing that we have to do with the absolute value. Okay? This is what we have to do. So now it's easy to find antiderivative. So I have x minus, and this is what? X to 1 over 2, right? So we'll have what? 2x to, well, it's x to 1 over 2, you have to add 1, right? So you get 3 over 2, and over 3. And this one is from 0 to 1. And then the next one, well, it will be 2x to 1 over 2 over 3 minus x. But this time we have to go from 1 to 4. Little inconvenience here with the second one, but at least. So now we're going to substitute. So we'll have 1 minus 2 over 3. That's what we have when we substitute 1. Minus 0. And then plus. Now we're going to substitute 4. So 2 times 4 to 1 over 2 over 3 minus 4. That's the first substitution. And minus now 1 substitution. 2 over 3 minus 1. Careful with this, okay? You want to make sure you're putting the numbers in the right way. So, again, like I told you, I really don't care that you go from here with really step-by-step process. Just give me the answer right now, and this should be okay. So the answer will be negative. Should be positive because even if you look at the graph, larger portion is what? What, right? And you bring in everything. And remember, it's absolute value, so you're bringing everything like up, so it cannot be negative. So this will be positive 2. Okay? Now, again, how do you check if you got this right? Well, you're going to go to your calculator, but now instead of just the function, you're going to put absolute value of that function, because you want to see exactly the original one. Okay? So if we put the original one, this one, into calculator, so don't forget, go to math, go to the right numbers, that's ABS, that's absolute value, and then you put square root of x minus 1, close the parenthesis. So when you graph, that piece that was on the bottom will be where? On the top, right? And now you go with the second, trace, I want to see just the picture. Go 7, and you go from 0 to 4. Now we may not get 2 right now, we may get 1.99. I don't know. Did we get 1.99? Yes, we did. But remember, the answer is what? 2. So, again, why we're not getting exactly 2? Because it's the method they calculate using to calculate the integral. But that's what we have. So we have the right answer. So don't forget absolute value. The next one, let's say we have, and I'm just giving you some examples. Remember, I'm not saying this is your test. So 6 will have integral cosine of x, then times by sine of x dx. So, do we need substitution here? No substitution. What do you think? So, substitution, yes, no? So what will be our substitution? Looks like, okay? We'll say this way. Looks like u equals sine of x. And I told you, sometimes we're not sure, and that's fine. Put it in, see what you get. If everything goes fine, there's no problem. So du over dx will be cosine of x, derivative. Then dx will be du over cosine of x, and it seems everything will be fine here with this. So we have integral cosine of x times by sine of u times by du over cosine of x. So these two will be canceled. And we have just integral of, sorry, I'm writing the answer already, sine of u du. So what is the antiderivative of sine? Negative cosine, right? So we have negative cosine of u plus c. And again, we had indefinite integral. So going back to substitution, so we get cosine of what? Sine of x and plus c. Then you can double check and see if it's right. How can you check if it's right? Take the derivative, right? Don't forget this is composition. So as I mentioned before, substitution method is opposite to the taking derivative using the chain rule as the composition. So any questions here? So now we're going to try to do one with the let's say definite integral. So integral from negative pi over 6 to pi over 6. And let's say we have sine of t over cosine square of t dt. So definite integral, still we need to have antiderivative, right? Because of the second fundamental theorem of calculus. So what do you think we go with here? We have two methods of solve this integral, okay? So what do you see? I see substitution. Okay, we can go with substitution, maybe something else. Miniko, what do you think? Can we go without substitution? Now remember, if there's a chance not to use substitution, better not to use it.
Split it into tangent quote cosine.
All right, that's good. I heard that. That's right. We're going to split. And I'll also show the substitution, just a comparison. Okay, we'll see this. So when we say split, we'll have, well, how can we put this when we split? We can put 1 over cosine of t times sine of t over cosine of t dt, right? Can we do it this way?
Yes.
Okay. And it's always a good idea to check again for some other methods, not actually getting into substitution, especially with the definite integral. But anyway, so this will be what? 1 over cosine is what? Secant, right?
Oh.
And then tangent dt. So what is secant of t times by tangent of t? What will be the antiderivative?
It'd be
secant, right? This will be just secant of t. And you see, I don't have to worry about upper and lower limits. And when we put this in, we have secant of pi over 6 minus secant of negative pi over 6. And you can use calculus for this, okay? Now again, like I said, I'd like to see exact answer, so no really decimals. But to help yourself, you can put this into calculus. So what do we get? What is secant of pi over 6? 2. Well, secant of pi over 6, just go to the 3. Check. No? As the final answer?
Yes.
No. Will not be 2 square root of 3 over 3. Huh? So one more time. What is secant of pi over 6? So 2 over square root of 3? Oh, 2 over, right? I'm ahead of myself here. Then what? What about secant of negative pi over 6? It will be negative, right? So you'll have negative, right? Then we get what? Are we going to add this? Well, secant is what? Let's think about this. Secant is what? 1 over what? Cosine, right? And cosine is even function. You should get the same value. Secant of negative pi over 6. It will be the same, right? It will be what? 2 over. So the answer will be what? 0. Okay? So the answer is 0. Well, here's the question now. So when we got 0, so let's go start from the beginning. What did we overlook? Now we did everything right. We got 0 full credit, okay, right here. But I could go faster here. Because if you look at the problem, what do you see? We have symmetrical interval from negative pi over 6 to what? To pi over 6. So I could just check if my function even or odd, okay? And then see what I have. So if I take my function, again, I'll call it f of t. So I have sine of t over cosine square of t. So if I check if it's even or odd, remember we have to substitute negative t, right? So we get sine of negative t over cosine squared of negative t. Well, sine itself is odd, so it's negative sine of t. Cosine is what? Even, but it's even squared, right? So basically this will be what? Cosine squared of t. And that means what you got your negative original function. So that means this function is what? Odd function. And if we have odd function on the symmetrical interval, then what? It will be 0. So that's another way of doing it, but if you want to do this, you really have to prove it that function is what? Odd function. You can't just put 0. Because you can put this into calculus and get 0. Well, it's not exactly the knowledge, right? Except maybe how to put this into calculus. So that's this one. And we may look at the same problem quickly, but using substitution. So 2 ways, actually 3 ways, right? We can modify the function and use antiderivative. Going through the process, we'll get 0. Also, we can check if it's even odd, but again, it only works when we have symmetrical interval. If we don't have symmetrical interval, then even odd doesn't help at all. And the next one is the substitution. What do you think if we go with the substitution? What do we get? What will be the substitution? That's right. So u equals cosine of t. So then we have du over dt equals negative sine of t. When we take the derivative, then dt will be du over negative sine of t. But this one is the what? Definite integral, right? So we have to change the upper and lower limit. So if t is negative pi over 6, what will be our u? Square root 3 over 2, good. And what will be if you put pi over 6? What do you get? Square root 3 over 2. Now, what do you think will happen right now? Look at your upper and lower limit. What do you think? I will have what? Integral from square root 3 over 2, and again integral from square root 3 over 2, right? That's what I have. And then we'll have what? Sine of t, I'm just writing this. Here we get u squared. Now I know you don't see it, but if you look at your notes, you will see. We have u squared, and then we have du over negative sine of t. So these will be canceled, right? Negative goes outside. 1 over u squared du, and square root of 3 over 2, square root of 3 over 2. So what do you think the answer is? Now the question, like, do I have to do it, right? Do I have to do it, or I know it's 0 now? Can you prove it that this one is 0 just by looking at this? What do you see? One of the properties, right? So what it's saying, if your upper and lower limits are exactly what? Same, then the answer is what? 0. So you don't have to really go through the rest of the process. You can just put 0 here, and again, these two are the same. We had this property before. If upper and lower limits are the same, the answer is 0. So as you see, there are lots of things we can consider here. Again, we can just modify the function and solve, get 0, or we can check for even odd because of the symmetry, or we actually go through the substitution. And kind of lucky you that you have what? Upper and lower limits are the same. If they're not the same, then we have to what? U to negative 1, right? And find antiderivative and do the rest. We still get 0, okay? But that's what we have. So please don't forget this. There's some little hints that we have to pay attention to. Next. This one is what, 8? Let's say we have to integral from 0 to 1, 5v minus 5 to v power dv. Now, many students, if they see something like this, like all of a sudden they decided that we have to go through the substitution. Okay? Do we go through substitution here? Do we need substitution here? Shouldn't you just go from left to right? So, we can have antiderivative here, yes, no? Can you have antiderivative here? Yeah, right? So we don't need any substitution, okay? So antiderivative here will be 5v squared over 2, right? Minus, now what is antiderivative of 5 to v? 5v over natural log of 5. Forget this. And this whole thing will be from 0 to 1. Very simple problem. Okay? So if there's a chance that you just go from left to right, always try it. Now don't forget, it only works with addition or subtraction, right? Not with multiplication and division. So if we substitute 1, we'll get 5 over 2 minus 5 over natural log of 5. So that's the first piece. And then we're going to substitute 0. So 0 will be here. But here you will have 5 to 0 is what? 1. So you have 1 over natural log of 5. So slowly, 5 over 2 minus 5 over natural log of 5. And this is 0, so plus 1 over natural log of 5. So the answer is 5 over 2 minus what? 4. Yes, and you don't have to give me any LCDs here. This is a good answer, but no decimal. So again, we don't need any substitutions. 9. So let's go back to indefinite integral. So how would you solve this problem? Do we go with the substitution? So what do you mean? So basically what you're saying, we should look at this like this. Well, let's try and see what we have. So let's square the top. So we have 1 minus 2x plus x squared and over x squared dx. All right, so got to this point. Open parentheses. What about the next step? What would you do next? Yeah, you can do that too, right? Or you can just what? Divide each term on the top by what? X squared. But yeah, I go with that too. You can move x squared to the top, will be what? X to what? Negative 2, but then you still have to what? Distribute. Okay? So either way, it's a good method. It doesn't make any difference. It still works. So if you want, we can just basically divide. That will be easier. So here you'll have x to negative 2. Again, 1 over x squared, right? Then minus 2x over x squared gives us what? 2 over x, but remember I don't want to have over x. Well, actually 2 over x will work fine because I see what that is, right? If I go with the antiderivative. And then plus what? 1. So again, why I didn't change this to 2 times x to negative 1? Because that doesn't help if you find antiderivative. Because x to negative 1 is actual natural log, right?
Everything okay.
So let's find antiderivative. So what is antiderivative of x to negative 2? Negative 1 over x, good. Here we have antiderivative of 2 over x.
It'll be negative 2 natural log of x.
Okay, good. And the last one? Plus x. And plus c. And again, don't worry about here LCD, okay? This is a good answer. We don't care about that big, huge function. Just this piece. Okay? So again, with this problem, overall, students may think that they should use substitution like u equals 1 minus x over x, right? Because it looks like a composition. Well, not a good idea. That will not lead us to anything. So we just have to open parentheses and see what else we can do just by
Just got
simplifying.
this one. The first.
Okay. For 10, let's say we have integral x over 1 plus x to the fourth dx. So going back to, well, working with indefinite. So what do you think we can do here? This one can be complicated if you cannot see it. That's inverse tangent, right? So this will be inverse tangent, so if we do this step by step, it's going to look like this. And then our substitution here will be u equals what? What is it? X squared, that's right. So this can be different, okay? Because we can think like, okay, maybe I can use like 1 plus x to the fourth as my substitution. And then you have to solve for x, and that's not going to work. So you really have to see that there's inverse tangent hidden inside. So du over dx will be 2x, and dx will be du over 2x. So this is what we have, and going back to the integral, we have x, 1 plus u squared, if you go back to substitution, if you work with the substitution, and then du divided by 2x. So canceling x's, moving 1 over 2 outside, and you have 1 over 1 plus u squared du. And now we can see that 1 over 1 plus u squared is the inverse tangent, right? So you will have 1 over 2, inverse tangent or arctangent. The way you want to write this doesn't make any difference. And plus c. And now we'll go back to substitution. And we have 1 over 2. Inverse tangent of what? X squared plus c. So that's the answer. So I don't know, like if I pick all the problems that I showed you, let's say, so far, this is probably the most difficult one to see. But some of you say like, well, fine. Well, that's fine. And let's take a look at the last one. From integrals. So the last one, 11, will have integral from -5 to 5 dt over t minus 4 quantity squared. Now, again, it's a definite integral, and again, we can kind of look at this problem from a different point of view. But do we see the symmetry? Now, if you check if it's even odd overall, okay, if you check if it's even odd, what do you think you'll get? Even? Yeah, we can check, right? So, let's check if it's even. So, I'll take my function. And then I'll check for this. So I will have what? Negative t, right? I substitute. Minus 4 squared. So far so good, just substitution. Then 1 over, pull out negative, like this. Then this is -1. -1 squared is what? Positive. So you will have something like this. What do you think? Neither, okay? So that doesn't work, okay? So we cannot think about even odd. It's neither. But what else we missed? Remember what else the theorem was saying? The second fundamental theorem of calculus. What's the first phrase? If what? F is continuous, right? What do you think? What's the domain? So except, not x, right? T, so t does not equal to what? 4. And 4 is where? In this interval, right? And overall, it's a rational function, so we have infinite discontinuity, which we cannot fix, okay? So overall, my domain is saying that 4 is inside of this interval, so the answer is what? No. Well, let's say you overlooked this, okay? Let's say. I'm going to copy the problem again without
Teachers, at this
putting
time,
you on.
can we get the
Let's say you overlooked this.
freshman basketball
I'm going to
team?
solve this problem.
Good
So
luck,
you
girls and Burley.
will-
Just the freshman girls. Thank you.
Yeah, I'd probably go with the substitution. I would do that too. So u equals t minus 4, right? That will be the substitution. Then you get du over dt equals what? 1, right? And you get gt equals du. We will maybe change upper and lower limits, obvious. So when t is negative 5, then u is what? Negative 9. T is 5, then u is what? 1, right? So far we do not see any difficulty, okay? We're just doing the problem. And then when we go to the problem, we have negative 9 and 1, and here you will have 1 over u squared du. And basically what that means from negative 9 to 1, and we had u to negative 2 du. So again, if you look, everything goes smoothly. There's no red, something that can stop us. We're just doing this. And this will be what's the antiderivative of u to negative 2? Negative 1 over u, right? And then you get from negative 9 to 1. So I'll put negative outside, so I'll have what? 1 over 1, right? Minus what? Negative 1 over 9, right? If you substitute, yes, no? I'm not sure, but again, I pull out negative, so put 1, it's 1 over 1, right? And then you put negative 9, so you get 1 over negative 9, right? So when you do this, again, put this into your calculator, you get negative 10 over 9. You got the number, do you understand that? But that's the wrong number. So not every problem, when you do like this one, you remember again, the answer was what? Does not exist. But if I overlook the domain here, I'm just going to do the problem. Most of the time, it's workable. I do through the whole thing, go through the whole thing, and I'm getting something. But this is the wrong end. Okay? So, again, use your calculator. The calculator will give you some hint. Okay? Maybe we'll say, well, problem with the domain, remember? So that means it does not exist. But if you just put does not exist without explaining, I will not give you credit. I will give you 1 point out of 5. So, well, that doesn't have much to pass, right? So careful with this. So that's this problem. So again, we saw the problem with the domain, and we said does not exist. When I did the problem, I actually got the number, which is wrong number. So that's about integrals. So what's left for us to refresh, and we'll still continue tomorrow, okay? We'll talk about the first theorem. So fundamental theorem calculus 1. So for number 12, I will say I have 2 questions because we'll have same problem but with different example. So same question better, I should say. So for example, we have function. So g of x equals integral from 3 to x. And I don't know if you remember the theorem overall, but the first theorem does not solve anything overall. The first theorem just makes the connection, okay, between integral and antiderivative. That's all. And the question here is to find the derivative of this function. Do you remember how we did this? Right. Basically, the theorem says what? Take that x, right, and what? Substitute into your function. So it will be x squared minus 3, and that's it, no plus c's. I see this all the time. For some reason, I don't know where we're getting those c's. But that's what we have, x squared minus 3. Now, don't forget, the theorem says what? The number has to be on the bottom, right? And here you must have just x. So that's the simplest. Now, let's take a look a little bit more complicated when, for example, our function looks like this. From 2x to 3x of u squared minus 1 over u squared plus 1 du. And the question is the same here to find the derivative. And right away I can see the function does not fit into the theorem because I have what? X's on both, right? Lower and upper limits. So before even I take the derivative, I have to split this. I have to fix this. So I will split this 2x, and here, again, remember we talked about this, you can put any number, but just be careful with the function inside. Make sure you will not have division by 0. But I'm perfectly fine here because u squared plus 1 is always what? Positive. So no matter what I put there, I will never get 0. You understand? So if you want to put 1, that's fine. And then I have u squared minus 1 over u squared plus 1 du. And the second integral will be from 1 to 3x. And it's the same function. So again, we're not finding derivative yet. We're just splitting, fixing. Now I have another problem here, right now, with the first one. Because of what? Because 1 is on the top, right, as a number. It has to be on the bottom, and we know how to fix that. How do we fix that? Right, we put the negative sign, so you get from 1 to 2x, u squared minus 1, u squared plus 1 du, and the other one will stay, looks good. And only now you can take the derivative. So, y prime. Negative. Well, the rule is still the same. What do? We take what? 2x and substitute for u. So if you put 2x here, what do you get? You get 4x squared minus 1. What do you get here? 4x squared plus 1. But there's one little addition must be added, or I would say multiply, right? We have to multiply it by 2. Now, do you remember where that 2 coming from? We must take the derivative of 2x, right? It's not just x as in theorem. And I told you, if you have anything different than x, even like negative x, you will multiply by negative 1. You must take the derivative. Even like technically, I mentioned this to you before. If you go back to this problem, to a, I could say I took the derivative because the derivative of x is what? 1. So times by 1 is the same, right? You understand? So we're taking the derivative anyway, kind of. So this is what I have here. And then go to the second one. I get 9x squared minus 1 over 9x squared plus 1 and times by what? And times by 3. And that's it. There's nothing else I want you to do. You don't have to find LCD. Okay? But one thing what I want to tell you. When you're substituting 2x, make sure you actually substitute and give me 4x squared, not 2x parentheses squared. You understand? You can handle that. But that's all for this problem. This is the derivative. So nothing else we have to do with this. Any questions? Okay? So, what time? It's 3 o'clock. We can do one more. So, we did integrals. So we had first theorem, second theorem right here. Now, let's talk about the very beginning when we had to talk about limits of Riemann sums and all that. Now, I'm making this, well, I only have 5 minutes, so I'm not going to do the big problem. I'm going to do small problem, okay? But then tomorrow we'll come back to this and do the problem. Now, one thing before I forget, so you will be taking the last exam on Monday, what? Tuesday, right? Monday, Tuesday. But I really want to have class. I don't want to cancel class because I really want to go over the final review, okay? So I don't want to cancel the class. So we will be here on Monday and Tuesday, okay? And testing center, even in Burley, they will not close at 5 like normally on Friday. That's what they do. So you have some extra time. But I really don't want to lose any time because I want to go over your exams. We want to look at any mistakes that you made. If you did everything right, that's great, okay? But still, review will have because that chapter 2 was far, far away, okay? So we really have to refresh. So again, I don't want to cancel class. So we have class on Monday and Tuesday, okay? So let's finish with this quickly before we leave. So number 13. So there will be the problem like this. You will be given a limit of Riemann sum. And I really want you to kind of remember the questions here because I don't want you to get confused with something too easy. And actually I want to square this. So I have this limit of a Riemann sum. Now, it's not just f of x, I actually have real function inside. And question A will be to express this limit of a Riemann sum as integral, okay, on interval from 0 to 1. So how would you express this as integral? We'll have integral from what? From 0 to 1, right? And what is your function now if you look? Right, 1 square root of 1 minus x squared, right? And what? And that's the first question that we have to answer. Very simple one. Now the second one actually will say, well, find this integral. And I'm specifically saying on the exam, use antiderivatives. Because for some reason, students will start doing limit of Riemann sum here, but it's almost impossible because if you look at the square root. So what do you have to do? You just have to find antiderivative. This is normal process. That's what I want you to do. What is antiderivative of 1 over square root of 1 minus x squared? So that would be inverse what? Sine, right. So you will have inverse sine of x and from 0 to 1. So again, the first question just to set up. The second one is actually to find the area or find integral using antiderivative. So no limit and all that stuff. Well, so we have some inverse sine of 1 minus inverse sine of 0. So what do you get? 5 over 2, right? So inverse sine of 1 is what? 5 over 2. And inverse sine of 0 is 0. So overall we get 5 over 2. So we're going to stop right here. Now, overall, as the overview for the exam, you basically almost got everything except well, 3 problems, okay? So we're going to look, actually, well, 4. We're going to look at those 2 more, all right? So keep working, start again, refreshing. Formulas for derivatives, formulas for antiderivatives, okay? That's what we want to do, just to make sure you have them in your memory. And tomorrow we'll finish with the review for the exam. And if we have extra time, well, we'll pick up maybe a couple extra problems, or we'll look at some problems related to the final exam. So I'll see you tomorrow.
Thank you.
You're welcome. So when is the pizza party?
after the final.
They will send you a little can of smell. Okay.
You're more than welcome to come. Show up. Spam.
Well, I don't know if you saw actually, there's actually people in Canada sending air to China. So you see they're making money just from Canadian air. You missed the opportunity, right? That was really kind of innovative.
Really?
Rational expression can be used in ones with fractions.
The live action relax, the large. Not the live action, the animated.